We see all these crazy videos online of humanoid robots, you know, doing backflips and dancing and picking stuff up like it's nothing.
It's mind-blowing the stuff they can do now.
But have you ever stopped and thought about, like, how long can they actually do that stuff?
Ah, the battery life issue.
Exactly. It's a kind of a buzzkill, right? Like,
Yeah.
all that amazing tech, but then their battery dies, and suddenly it's nap time for the robot.
Hmm.
Not very helpful in a real-world situation, especially if you need them for something important.
It's a huge limitation for sure. You're absolutely right. If we really want these humanoids to reach their full potential, to be out there in all sorts of environments doing what they do best, we got to crack this whole energy endurance thing. Batteries just don't cut it right now.
And that brings us to today's deep dive, Kawasaki Heavy Industries, or, as the cool kids say, KHI.
KHI, yeah.
A company with a history that goes way back, like over a century. They're giants in industrial robotics and heavy engineering. But what makes them extra interesting in this conversation is that they're super into hydrogen.
Oh yeah, they're all in, not just dipping their toes, they're diving headfirst into the whole hydrogen scene.
Right. They're involved in the entire hydrogen value chain,
Yeah.
from production to transportation to using it. It's like they've got this complete picture of how hydrogen can work in the real world.
Which gives them this really unique advantage when you think about it. They're not just thinking about robots, they're thinking about the whole system that supports those robots.
So for this deep dive, we're going to focus on KHI's work with humanoids, specifically their journey from their current Kaleido series to this super cool hydrogen-powered concept they've got, which we're calling CORLEO.
CORLEO, yeah. Definitely one to watch.
We want to get a sense of where they've come from, where they're at now, and what this hydrogen future might look like for these robots. A future where they can operate for, like, way longer and do even more incredible things.
That's the dream, right?
Totally. And to really appreciate where they're headed, it's worth looking back at where KHI started in robotics. Because they didn't just start building humanoids out of the blue. Back in 1968, it's a whole different ball game.
Oh, yeah, totally different. Back then, it was all about industrial robots, those big, powerful arms you see working in factories, especially in the auto industry. That was their bread and butter for decades.
So they've been in the robot game for a long time.
A long time. And that experience, all those years of building those super reliable, heavy-duty industrial arms, it's like the foundation for everything they're doing now with humanoids.
I can see that. It's like they learned all the basics, the core principles of how to make a robot move, how to make it strong and dependable.
Exactly. Kinematics, dynamics, control systems, you name it. They've got this deep understanding of how to design and build robots that can handle serious workloads. And all that know-how is incredibly valuable when you're trying to tackle something as complex as a bipedal robot.
It makes sense. They didn't have to reinvent the wheel. They just had to figure out how to make that wheel walk on two legs. But it seems like there was a shift, right? Like at some point, they decided to move beyond those industrial settings and start thinking about robots that could operate in more human-centric environments. What prompted that change?
Well, a few things. For one, there were some major events like earthquakes that really highlighted the need for robots that could operate in really dangerous, unstructured environments. Places where it's too risky to send humans.
Like search and rescue missions after a disaster.
Exactly. And then you've got this growing aging population, which created a demand for robots that could assist people in more everyday tasks.
Yeah.
So you've got these pressing societal needs that were starting to push robotics in a new direction.
And that brings us to Kaleido, which started appearing around 2015, 2017.
Yeah, that's when things started getting interesting.
It's fascinating to compare Kaleido to other famous humanoids, like Boston Dynamics' Atlas, which is all about agility and doing parkour, and Honda's Asimo, which was more about human interaction. What was the philosophy behind Kaleido? What were they trying to achieve?
Kaleido is all about robustness and practicality. It's built to be a workhorse, especially in those disaster scenarios we were talking about. While Atlas is doing backflips and Asimo is shaking hands, Kaleido is designed to be dependable, to be able to handle tough tasks in demanding conditions. Strength and stability over flashy moves, that's their motto.
And we saw that in those early demos, right?
Yeah.
Where walking on two legs, climbing stairs, getting up from a lying position,
Yeah.
all essential skills for navigating a disaster zone.
Totally. And what's really interesting is how Kawasaki's background in heavy machinery influenced Kaleido's design.
Oh, how so?
Well, they're not just building machines, they're building machines for extreme conditions. Think bulldozers, excavators, stuff that has to withstand a lot of stress and keep working. That focus on resilience, on building things that can take a beating, it's deeply ingrained in their engineering DNA. And you can see that in Kaleido. It's not about being sleek or lightweight. It's about being tough, dependable, able to handle whatever gets thrown at it.
So it's like they took their expertise in building like a tank and applied it to a humanoid robot.
Basically.
So what do the current versions of Kaleido look like? What can they do?
They're pretty imposing figures, I gotta say. About 1.8 meters tall, over 80 kilograms. Definitely built for strength.
Not exactly nimble little guys.
Not really. But don't underestimate them. They can walk on two legs, navigate uneven terrain, climb stairs. They still have that self-righting ability, which is crucial. And they can carry a lot of weight. We've seen them carrying rescue dummies, equipment, no problem.
That's impressive. What about interacting with the environment? Can they use tools, operate machinery?
They're getting there. They've shown they can operate valves, handle tools. But fine manipulation, the really delicate stuff, is still a work in progress. Think of it this way. They're great at grabbing a beam, but maybe not so much at threading a needle just yet.
And how are they controlled? Are they fully autonomous, making their own decisions out there?
Not usually. Most of the time, they're controlled remotely by a human operator. Teleoperation, it's called. But they do have some semi-autonomous functions to help with stability and navigation. So the human is in control, but the robot can handle some of the basic stuff on its own.
So if you had to sum up Kaleido's niche, what would you say?
It's a tough, reliable workhorse for challenging and potentially dangerous situations. It's not about acrobatics, it's about getting the job done. Disaster response, carrying heavy gear, clearing debris, that's where it shines.
And you mentioned Bex the Ibex earlier. That's a four-legged robot, right? How does that fit into KHI's overall robotics strategy?
Bex is kind of a side project, but a really interesting one. It's designed to carry heavy loads, or even people across different types of terrain. The coolest thing about it is that it has retractable wheels in its knees.
Wheels in its knees.
Yeah, so it can switch between walking and rolling depending on the surface. It's not a humanoid, but it shows that KHI is exploring different approaches to mobility, trying to find the best solution for the problem.
Always innovating. We also came across some interesting theories about the name Kaleido. Any insights on that?
Well, officially, KHI hasn't said anything, but it seems pretty obvious that it's connected to kaleidoscope, right?
Yeah.
Suggesting its versatility, its ability to do a lot of different things.
Multifaceted, like a kaleidoscope.
Right, but there's also this fun theory that it might be a nod to karate.
Karate, now that's unexpected.
Yeah, the thinking is that it refers to the combination of power and control that Kaleido embodies. It's strong, but it can also move with precision.
I like that. Powerful and precise. So we've talked about KHI's past, their current work with Kaleido. Let's dive into the future. This hydrogen-powered concept, CORLEO. This seems like a potential game changer in terms of solving that energy problem we talked about.
Oh, absolutely. Hydrogen fuel cells could be the key to unlocking the full potential of humanoid robots. We're talking about going from hours of battery life to potentially days.
That's huge. Why is hydrogen so much better than batteries for this?
It all comes down to energy density. Hydrogen packs a lot more energy into a lighter package compared to even the best batteries, and refueling is way faster. Imagine filling up a robot like you fill up your car. A few minutes and you're good to go. No more waiting around for hours while the battery charges.
And this is where KHI's expertise in the hydrogen world really comes into play.
Totally. They're not just building robots, they're building the infrastructure to support those robots. They're involved in production, liquefaction, transportation, the whole shebang. They even built the world's first liquefied hydrogen carrier ship, the Suzo Frontier. They know hydrogen inside and out.
So they're not just thinking about putting a hydrogen fuel cell in a robot. They're thinking about how to fuel that robot in the field, how to make the whole system work.
Exactly. So when we picture CORLEO, what are we seeing? It's like Kaleido, but with a hydrogen heart, right?
That's the basic idea. It's got all the toughness and capabilities of Kaleido, but with the added benefit of hydrogen power. Longer missions, more endurance, the ability to do more for longer. What kind of possibilities does that open up?
It's pretty exciting to think about. Imagine a robot that can operate for days in a disaster zone, searching for survivors, assessing damage without needing to stop and recharge. Or a robot that can do long-duration inspections and repairs on pipelines or offshore platforms, places that are hard to reach and dangerous for humans.
We could even have them doing security patrols or transporting goods across vast distances.
Exactly. The potential applications are pretty much endless.
But it can't be easy building a hydrogen-powered humanoid, right?
Yeah.
There must be some serious challenges.
Oh, there are. One of the biggest is just fitting everything in. You've got the fuel cell stack, the hydrogen storage tanks, which could be high pressure or cryogenic, plus all the thermal management systems to keep everything running smoothly. And you have to do all of this while maintaining the robot's balance and making sure it can still move effectively. It's a huge engineering challenge.
And safety has to be a top priority, right? I mean, we're talking about hydrogen here.
Absolutely. They need to make sure those tanks are super robust, that there are no leaks, that the whole system can withstand impacts and shocks, and you have to manage the heat generated by the fuel cells. It's a lot to think about.
It sounds like an incredibly complex puzzle. That fact about KHI building that massive hydrogen carrier ship really shows how they understand hydrogen on a huge scale. But shrinking that technology down to fit in a robot is a whole different ballgame.
Totally different. And that idea about CORLEO standing for companion robot based on liquefied hydrogen energy operation, even if it's just speculation, it kind of hints at their thinking.
It does. Like they're trying to bring their large-scale hydrogen expertise to the world of robots.
Exactly.
So realistically, how long do you think it'll be before we see a hydrogen-powered humanoid like CORLEO out in the real world?
It's going to be a while. There's a lot of R&D to be done. They'll probably start by testing the technology on simpler robots, maybe something like Bex.
Baby steps.
Exactly. They need to make sure it works reliably before they try it on a more complex machine like CORLEO. And they'll need advancements in materials, science, fuel cell technology, AI, all sorts of things. It's going to take time.
But it's definitely an exciting goal. And it's clear that KHI is serious about building robots for the real world. Robots that are tough, reliable, and can handle the demands of challenging environments.
Absolutely. Kaleido is proof of that. It's a capable machine ready to work.
And CORLEO, well, it's a glimpse into the future. A future where energy is no longer a limiting factor for these amazing machines.
It's a future where robots can operate for days, weeks even, without needing to stop and recharge. That's a game changer for sure.
It is. And KHI, with their deep knowledge of hydrogen and their commitment to practical robotics, well, they're in a great position to make that future a reality.
Agreed. It's going to be an interesting journey to follow.
It definitely is. So to our listeners, we leave you with a thought. Imagine a world where truly long-endurance humanoids are a common sight. How would that change our approach to disaster relief, to infrastructure maintenance, to, well, everything? What new possibilities and new challenges would these persistent robots create? It's something to ponder as we move towards this exciting and maybe slightly unsettling future.
Definitely something to ponder.
Thanks for joining us on this deep dive.
My pleasure.